Hi guys, welcome back to the channel. In this week's video, we're continuing our journey using DBT on top of Snowflake. And I'm going to talk you through some advanced materializations and get into a lot of detail about how you go about implementing those. Specifically, we're going to cover tables, views, incremental, and ephemeral. And we're going to talk about the different pros and cons and when you would use each of them before diving into an example to show you how it works. And don't forget, if you get good value from these videos, like and subscribe and share them with other people so they can also benefit as well. And if you stay to the end of this video, I'll let you know how you become a member on our Mastering Snowflake exclusive program.
So let's start by talking about the first type of materialization in DBT, which is the view. This is when your model in DBT is rebuilt as a view on each run, and we use the create view statement behind the scenes when DBT runs that model. So the pros here is obviously no data is stored. It's a SQL statement encapsulated in a create view. And that means it always contains the latest data, because when you query the view, that's executing against the source data beneath it. And therefore, you'll always see the latest copy of that data because it's running on the fly. The downsides, though, if you've got complex logic or quite complex or intensive transformations, that may impact performance and that might slow down that end user experience. So the advice from DBT is to always begin at the outset with views, see how that works and see what the performance looks like in your own environment before you consider moving to different types of materializations, which we'll cover in a second, as required. So if you start with views and then you find the performance is not optimal, you can then look to move to different materializations as a step-by-step process, but always try to start with views. And in terms of use cases, they're best suited to light business logic, which focus on presenting data for end user or application consumption. So what I mean by that is alias in certain columns, casting data types. Ideally, this would have been done perhaps a bit earlier on in your transformation process, but that's not always the case. You may have very specific use cases where you need to present the data in a certain way for that requirement. And this is where a view can come in very handy. The next type of materialization we're going to talk about is a table. Your model is rebuilt as a table on each run using the create table statement. That means it's fast to query, your data is pre-computed and it's stored on disk, ready to go. As part of that transformation process, depending on the complexity and the number and volume and size of records you're dealing with, tables could potentially take a long time to rebuild. And obviously new records and the underlying source data aren't actually added to the table unless you run a transformation to update that. You should look at using the table materialization for any models really being queried by BI tools, just to provide that fast user experience, especially if you've got quite a large user base who are using something like Tableau or Power BI and are running a lot of queries concurrently throughout the business day. It makes a lot more sense in that case to physicalize that data as a table. Also, you can use the table materialization for any slower transformations that are used by many downstream models. So what I mean by that, if you've got complex transformations or business logic you need to apply to your data and you've got a lot of dependent downstream models within your DBT project that rely upon that, then it makes sense to use a table at that point in your process to speed up all those dependent models further down the track. The next type of materialization we're going to cover is the incremental materialization. So this allows DBT to insert or update records into a table since the last time DBT was ran. So this allows you to just transform the new or change records within your data, but it does require additional configuration, which we'll see in a second, and it's considered an advanced usage of DBT. So you need to make sure that you're comfortable and confident with using this approach. Best suited for high volume transactional data or event style data where you're getting a lot of new data arriving quickly and you don't want to rebuild that table every time. And on that point then, you probably want to consider a switch to an incremental model when your DBT runs start to become too slow because you're just processing a large amount of data each time. And on that point, you're probably best to switch to an incremental model when your DBT runs become too slow because you're looking to process a large amount of data. Our fourth and final type of materialization we're going to cover as part of this video is the ephemeral materialization. This model doesn't actually physically reside or exist within the database, rather it's created as a CTE actually when you run the DBT command. So this still allows for you to plug reusable logic into your models, and it helps to reduce the number of objects in your database, so that potentially that clutter of objects. You can obviously segregate things by schema to make it more readable and easier to find objects. But on a large implementation, if you're dealing with thousands of objects, it could be useful to introduce this kind of materialization into your project. Now, because it's created as a CT kind of on the fly, you can't select directly from this kind of model, and you can't reference these models within DBT. In a previous video, you may remember we covered how you can reference other models, so DBT then can work out dependencies between them and draw a lineage diagram. In this case, you can't necessarily use that functionality in the same way. And because these models don't physically exist in the database, it can make it more difficult to troubleshoot or debug if you end up with an issue because they only exist at runtime. So what are these suited for then? Well, if you've got lightweight transformation or some data cleansing processing that you need to perform early on in your DAG or in your data pipeline process as part of your DBT project, this could be a good candidate to consider for those use cases. And also, you don't want a lot of dependent downstream models waiting to run off the back of this. So 1 or 2 is fine, but once you start getting 5+, you probably don't want to be using this just for performance purposes, and also just to make it a bit more robust in terms of any troubleshooting that you may need to consider further down the track. Also, as I mentioned before, you can't select directly from these models, so it's not going to be a valid use case to choose one where it needs to be queried directly. Let's take a look at that next in Snowflake. So we're back in Snowflake, and you can see on the left-hand side, we've got our objects that we've created previously from our DBT project. What we're going to do, we're going to clean this up first of all by just dropping the schema. So now we've dropped the schema, let's just refresh this window, and we can see our DBT A-Martin schema is gone. If we go back into our DBT project and we go into our DBT project YAML file, as a reminder, you can set your materialization at the project level and specify different materializations for different folders. In this case, so we're heading back into DBT Cloud and into our project, and you might remember from a previous lesson in our DBT project YAML file, you can specify the materialization at different folder levels within your project. So here, if we expand our models folder as a reminder, we've got Mart and we've got staging, and we're telling DBT to make everything in the Mart folder materialize as a table and everything in the staging folder to materialize as a view. And as it says in our YAML file here, you can also override this at an individual model level by specifying a config block at the top of our model. So we've looked at this in a previous example, but just to remind you what that looks like, is that we can add a config block at the top of here, which looks something like this. And if we save that in there and run dbt run, it would create it as a table or it would create it as a view, and we could override the behavior within our project YAML file here. For now, I'm just going to remove that. So let's go down to our command line and execute dbt run. What this will do is dbt will go through all the models in the project, gather them up, work out where the dependencies lie, and execute them against Snowflake. So we can see that's ran successfully and we've processed 5 models. If I go back into Snowflake and refresh this, you can see I've now got our 3 staging models which have been created as views as we specified in the dbt YAML file right here. And we can see we've got our 2 tables within our Mart's core directory, which we specified as a table. So all looking good so far. So as a reminder, let's go into our view documentation within DBT, and clicking down on the right hand side, bottom right hand side, we can view the lineage graph. For the purposes of this demo around advanced materializations, I'm going to focus on fact orders, and I'm going to change it to different types of materialization so we can see how the behavior changes. So I'm going to go into our fact orders model next, and I'm going to show you then how you can override the project folder settings The first thing I'm going to do is I'm going to add a config block, which looks like this, where we can say we want to create fact orders now as a view, and we're going to override the actual DBT project YAML file. So we add the config block in, we make sure we click save, and then we go down to DBT run again. In this case, I'm just going to use the model flag and type in fact orders and run that model on its own. So you can see just fact orders, the model is ran. If we go into details, we can see it's now created fact orders as a view. If we go back into Snowflake now, that was what we had before. If we refresh our object browser, we can see now fact orders has moved from a table. So DBT has handled that automatically for us. It's actually dropped the table and it's replaced that with a view because we've overridden the project settings in the YAML file. So next I want to show you the ephemeral model, and to do that I'm actually going to go into our staging area and I'm going to choose our stage customer model, and again I'm going to use a config block to override the global behavior. Exactly the same as before. I'm going to click save. In this case I'm going to run stage customer. I'm also going to use the plus symbol to ensure that DBT includes any dependencies if there are any. I'm going to run that. Okay, now let's have a look at what's happened here. You can see it's processed two models, none of which are the stage customer model, because remember, when you use an ephemeral model, it doesn't exist within the database because it's calculated at runtime. Because we've used the plus symbol, along with specifying this particular model, stage customer in this case, that we want to run, DBT has included any dependent objects. In this case, it's our dimension and fact. If I go and expand the details of our dim customer, you can see it's using this CTE for stage customer now as part of the query. And this is what the ephemeral model does. It's using CTEs instead of actually creating a database object in the table. So it's generated at runtime behind the scenes, and it's embedded then within the statement that's used to create the model downstream. So this is where it can get tricky if you need to get in and troubleshoot anything that's going wrong. Because everything's getting created on the fly during runtime, it makes it very difficult to track any particular bugs that you may have introduced during development. So use them sparingly is the underlying message, I guess, here, and just going back to the best practices that we talked about at the top of this video. If we go back to Snowflake though, and we refresh it, we can still see we've got the stage customer as a view. So when you do switch to the ephemeral model, DBT doesn't actually look to replace or drop an existing object. If it was a table of view beforehand, it will simply ignore it, but you will then need to remember to go in and clean that up again if you're doing an incremental deployment to your database. So let's move on to look at an incremental model now. And to do this, I'm going to go into our models folder, create a new file, and I'm just going to call it orders.sql for now, just for the purposes of this demo. I'm not going to worry about structuring it into our project folders at this stage. And in there, I'm going to paste the SQL code. So I'm materializing this as a table initially. I'm using our stage orders model that we've already got in our project, and I'm simply just selecting from it. So if we have a look at what that looks like, so if we have a look what that looks like by clicking preview, there we go. We've got order ID, customer ID, an order date, and a status table. So we're going to use this to demonstrate our incremental materialization by adding records to this stage table in Snowflake. So the first thing is we're going to run our dbt run command for this particular model. Just going to make sure I've saved it as well before I run and execute that. Okay, you can see that's passed then. If we go into our details, we can see it's created the table with our orders data in there. Now the next question is, how do we tell DBT then to not create this new table every time and just to add new records? Well, this is where the materialization, the incremental one, comes into play. So we replace table with the word incremental here to tell DBT this is incremental materialization. But next we need to provide it with a date to let DBT know how to identify new records. So you can see we've got an order date column in the table already. If I go to my scratchpad here, I've written this query, select max order date from our stage orders table. If we preview that, we can then see it's returning our maximum order date in the table as it stands. Now, how do we integrate this query into our orders model? So if I flick back to our orders model, I've pasted these 3 lines in. So let me talk you through what these are. First of all, we're using some Ginger programming language variables as part of this model now. So the first one checks if it's an incremental load. And this checks 4 conditions. So it checks, does the model already exist in the database? Is that database object a table? Is the model configured with an incremental materialization? And was the full refresh flag passed to this dbt run? So you can force a full refresh by passing the flag in on your dbt run command. So we're saying if it is an incremental run, then we're going to apply the filter based upon the run that we ran last. And then we're using this Ginger variable here, and this represents the currently existing database object that's mapped to the model. So it knows what model it's in, and it caters for any recursive issues that you may get by using that special Ginger variable. So let's save that model, and we're going to run this again. Now remember, in our first run, it created this as a table. And so now our incremental execution is being processed and passed. Let's look at the differences in our details tab in the logs to see what's changed. So now you're seeing us creating a temporary table behind the scenes. It's referencing our stage orders table again, but this time, because it knows it's an incremental load, it's applying our date filter and it's using our target table to understand what's the maximum order date value in our target, and it's selecting everything from our source table that's greater than or equal to that particular date. So that's exactly what we want to happen. And then further on down here, if we scroll down in the logs, we can see then it does our insert into our table for any new records it's found. So we flick back to Snowflake a moment and look at our source and target table, and we're just going to do a count start from our stage orders table. We've got 99 records in there. And if we look at our target table, we've actually got 100 records following that incremental run. And that is because in our where clause with our date filter in there, we use greater than or equal to. So if I select everything from the orders table, you can see we've got a duplicate record in here because it's reprocessed this record. There just happened to be one record with the maximum order date in our staging table. It's reprocessed that again and added it into our target table, which is what we don't want because we're going to end up with duplicate rows. And we could fix it by going back into our project and just removing the greater than or equal to and run it like that. But also we may get records arriving late into our source table, so we may want to purposely apply an overlapping window, and we can absolutely do that, but then we need to tell DBT what to use as a unique key to identify the differences between records. So let's take a look at that next. And so the very first thing I'm going to do, I'm going to go back to Snowflake, and I'm actually going to drop our orders table so we can do a clean run. And I'll go back to DBT Cloud. I'll run our model again. This time, because it's the first run, we should see it just create a table without the incremental flag running. So our model is ran. Go into our orders, go into our details, and you can see because it was the first run, it's actually created the table and there's no day filter on there. Back into Snowflake, let's check our accounts. So we've got 99 confirmed in our source table, 99 now in our target. So we know they're back in sync. So let's go back to DBT. And now if you remember, we could have late arriving records coming into our staging orders table, and we want to now tell DBT the unique key on our target table and our source table to avoid any duplicate records in the future. Pretty easy to do that. We can just type in our unique key is equal to, in this case, it's order ID. And we know in our environment that we could get records coming through quite late, potentially up to 3 days late. So what we're going to do, we're going to add in a date add function, specify the day or time increment, as days. You go back 3 days and apply that. So we've saved that. We're going to run our orders model again. This time it should run as an incremental load, but we shouldn't see it add in any additional records. We should still have 99 in our source, 99 records in our target, because now it's applying the unique key. And I just got a failure because I didn't put a comma in there. So let's put that in, and then we'll run that again. That's now ran. Let's have a look at our logs. We can see it's applied our where clause filter this time because it knows the table already exists and it knows it's an incremental run. And again, further down here, we'll see it using a upsert. So we've got a merge statement going on here. So obviously Snowflake supports a merge statement. And because we've introduced the unique key now, it's joining our source and target tables using our unique key. When we've got a match, then we can update that record to capture any changes. And when it's not matched, then we're going to insert that value in there, which is exactly the kind of behavior that we want to see and expect. And it also caters for any late arriving records. Let's go back to Snowflake then to verify everything is as it should be. So 99 records in our staging table. We're expecting to see 99 in our orders, and we do. So now we want to simulate some inserts into our source table, our stage table. But at the moment, our stage orders table is a view. So obviously we can't insert anything into that. So we're going to go back into DBT Cloud. We're going to go to our stage orders. And we're going to copy this config block out of here. And we're going to put it into here. And we're going to override our YAML file settings. And we're going to materialize our stage orders table as a table. And we are going to run that in DBT. That's now complete. Let's just check it got created as a table, which it did. We'll go back into Snowflake now. When we refresh our object browser, we've seen our stage orders table move into our tables. Now we can come across to here and we can run our insert statement. So we're going to insert 4 new records into our orders table. We're not updating anything. We're just adding 4 new records in here. We go back to DBT Cloud and we're going to run our orders incremental model again. This time we should see there's 4 new records getting added. So again, just checking that it's applying our date filter correctly, which it is. If we go into Snowflake, we check our stage orders table. We've now got 103 records in there. And we've now got 103 records in our target. Finally, we'll do an update. On our stage table. And we'll set our status equal to processed, where our order ID is equal to 100. I will execute that and we'll see we've updated one record. Go back into here again, into DBT, run our orders model again. That's now ran correctly. Go back into Snowflake. Now our count of records should be the same, 103 in our source, 103 in our target. But this time, if I select the order ID equal to 100 in our target table, we should now see that's processed, and it is. So there you have it. I hope you found that useful. That's how easy it is to set up an incremental table load, as well as looking at the differences between the other materializations, tables, views, and ephemeral. In the last video, we also covered snapshots, which is the SED type 2, slowly changing dimension type 2, to track changes over time as well. I'll put a banner on the top of the screen now so you can go and check that out. But that pretty much completes our journey of using DBT with Snowflake, and we'll probably move on to some other videos next. But if there's something that you want to see, let me know in the comments below. In the meantime, keep watching, keep subscribing, new videos coming soon. I also wanted to let you know about our Mastering Snowflake program with myself that we run. It's an exclusive signature program to help you master Snowflake and learn how to design, implement, and scale solutions in the cloud. And I've designed this program specifically for those people who have either scratched the surface using Snowflake or who are stuck working with legacy on-premise technologies and haven't been invested in by their companies and have fallen behind in their career. And what I've done is packaged up my knowledge and experience of working with Snowflake since 2017 and learning how to package up Snowflake's out-of-the-box capabilities in a way where you can apply them in the real world to address common challenges. So this program isn't about theory. Of course, I need to introduce you to the concepts if you're new to Snowflake, and many of my members are, but it's really about introducing the theory and then in practice how you apply those in the real world. I've been through the pain of understanding what works and what doesn't. Now I've got a formula or a set of recipes, if you like, that show you how to do that. So the Mastering Snowflake program includes in-depth, on-demand video course content that I've created. They all include practical hands-on demos. I provide access to all the code, templates, and files that I use as part of those demos, so you can download them and use them freely. You may want to use them in your day-to-day work. You may want to take them and customize them and use them as a starting point. All members on the program get exclusive access to a members-only group where everybody can help each other out and share their knowledge and best practice and get expert advice. Finally, I also carry out a group 60-minute coaching call with all the members, totally optional, where you can ask me anything about Snowflake, data analytics, data strategy, data architecture, you name it, interview advice, and I can help you and give my input and help and support and guidance around that. Finally, you'll get lifetime access to all feature updates. Snowflake's changing and evolving. There's new features and releases every week, and you'll continue to benefit from those updates as well. At a high level, there's 10 modules. This is what we cover, everything ranging from the Snowflake architecture to getting data into Snowflake. And then once you've got data, how do you effectively use it, secure it, share it, and work with it to ensure that you get the maximum value from your Snowflake implementation. If you're interested, I've included the application link in the video description below. If this sounds like the thing that you're looking for and you want to supercharge your career, and if you're ready to take the ultimate step, I'd really encourage you to fill out the application form below.